Hello and welcome to today's video. Today I thought it was actually going to be a short video, but it's turned out to be a bit more complicated than I thought it was going to be. I'm going to be looking at the I2C interface again, but trying to see how to set the actual speed. Now with my other development environments and other systems, that is a trivial thing to do. But I'm using several libraries at the moment, particularly Adafruit libraries, trying to be consistent. And I found, actually setting the I2C interface is a bit more of a challenge than I thought it should be. So with that, I'll switch over to the code and we can take a look and see what's going on. So now we can take a look at the code. So what I have here is just a simple sketch just to clear the screen, the OLED screen. So just a normal, includes definitions, the constructor, constructing the display object, then we call begin from the display object, and then we can clear the display clears the memory. And then the display method actually causes the cleaned memory to be displayed, and then do nothing. So this is a very simple sketch. So when I first ran this sketch, I took a look with the scope. So let's do that now. Just upload the scope. Okay, let's do a capture. Okay, so then we've got a quick capture. Just save that to disk. Okay, I'll put it on the screen up here somewhere for you to see when I edit the video. But when I look at that, I notice that the speed is 400 kilohertz. Now, I thought it would be as simple as changing this underlying object. This underlying object is a class which controls the two-wire interface, which is the I2C interface. So it has something called set clock. So I thought logically, that if I set the clock speed to be 100 kilohertz, and we're passing the reference to the object, I thought that would set the clock speed to 100 hertz. So let's just upload that and I'll show you what we get. Okay, so that's uploaded and we have a capture. Just save that to disk, and again I'll show you what we get on the screen. Now, as you can see, it's still 400 kilohertz. This is where I went down a rabbit hole looking at the code. And I found a couple of things. The first thing I found was in the display constructor class. This Adafruit SSD 1306 library, if we put a comma at the end, suddenly shows a couple more parameters. And they're labeled clock during and clock after. Clock during is suspiciously 400 kilohertz. So let's just write this in just so we can actually see 400 kilohertz. And then it sets the speed to 100 kilohertz when it's not using it. So already this is doing something which I don't like, which is changing the clock speed for different devices. I believe it's okay as long as all the devices support the maximum speed. But if you try to have, set a clock speed faster than one or two of the chips support, I think you might get eventually some reliability issues. So anyway, taking a look at this, it's obvious that this is actually in the constructor class setting its own clock speed. Now, it's hard to say this 100 kilohertz whether this is actually applying, and I'll explain why. So when I noticed this, I started to take a look at some of my other libraries. Now, I have on this prototype board set up a couple of different chips or modules. I've got this BME 2800. And again, 2800. Okay, so this is the 2800. It actually uses the alternate address. Now, some things which confuse me is I'm not sure whether this wire 2 actually exists. Wire 2 dot. Yeah, wire 2 doesn't actually exist. Wire exists. So I'm not sure about their demo code. But anyway, so we'll do what we did before, which is we're going to so let's comment that one. I don't want that. So we're going to explicitly set the address and pass in the address of the wire class or wire object. So let's upload this. Oh, sorry. So I keep forgetting all of these libraries have different bloody speeds for the serial port monitor. So I'm just re-uploading that sketch. And then we can take a look at the serial port monitor. So we can see that we connect through to the module and we start getting data fine. But when I take a trace of this, we get a capture showing a clock speed of 100 kilohertz. So I thought, aha, maybe in here I can set wire dot set clock for 100. But when I upload this, take another capture. Not loading. Okay, so when I do this, guess what? I still get a clock speed of 100 kilohertz. So again, in here, no matter what I do, it's going to use a clock speed of 100 kilohertz. Now I thought, oh, maybe in this BME object, there is a way to set the speed, set the clock speed. Set sample, there's thousand, or not thousand, there's tens of properties we can set, sampling interval, sampling blah blah blah, but we can't set the clock speed. Okay, so how do I change the clock speed? Well, I dug into all this and eventually I found a file. I'll put the location of the file in the comments below. But basically, it's a default library that gets installed with the Arduino. Now, I managed to track down this file called twi.h. Now, I tried to open it with the Arduino, but the Arduino seems to be limited to opening just the sketch files. So anyway, undefeated, I opened it with my other development environment, which is Visual Studio. I use I've got Android development environment on here, microchip development. This is Visual Studio. But what I did find was in here, the variable, or not the variable, the define for TWI_frequency, which is set to 100 kilohertz. So I found the initial value where the 2Y interface or I2C interface gets its frequency from. Now, it seems like most modules take this and just use this as their initial value and then don't allow you to change it. So my real-time clock module, my real-time clock module is slightly different. The atmospheric sensor ignored all of my commands to try to change the frequency from a higher level. The real-time clock module was a bit weird. In the begin statement, where it first started to communicate to the real-time clock, it used the default value. But after that, I could set the clock speed using that wire.set. But it wouldn't allow me to change that for the begin method or begin function. And so when I tried that, what would happen was I would get one frequency, get the 100 kilohertz before the frequency. I'd get 100 kilohertz for the begin set of message exchange, and then I would get the 400 kilohertz message exchange from then on, which is a pain. So in the end, I came down to having to change. If I change it at this low level and save it, now when I go to my Arduino and I run this project, do a capture. Now I actually get a I2C speed of 400 kilohertz, so that works. So we're making progress. The only issue we still have is my annoying display, which have these two values, what do they call it, starting and after, begin set, what do they call it, clock during and clock after. So the only one that really is important is this first value, which is clock during, because it works. If you set this to 800, 400, 200, it is actually going to set the clock speed to that speed. Then afterwards, it's trying to set this. Now, this just becomes a complete mess. If you set it in the twi.h file to 400, every time you set the display is going to go to its speed 400 kilohertz. Then once it stops communicating, it's then going to try and set the speed of the I2C bus to 100 kilohertz again. And it's just a mess. So fundamentally, I don't think these libraries should be messing with the clock speed. They should be using whatever speed is set in the wire object that is passed into them. But they don't appear to be working like that. So my recommendation is to do two things. If you want to make sure that your clock is actually running at like 400 or 100 kilohertz or whatever speed that you want, go into the TWI interface, twi.h, and change the speed in that file. And if you're using this display module, which is quite a common display module, make sure you set both for 100 to 400,000. Set both of these values to the same thing. So now we have most of the libraries will be taking the clock speed from that twi.h file, which is 400. The OLED display is going to be using 400 and is going to be trying to set it to 400. So this is the way I found to be able to get the most reliable I2C bus to be consistently 400 kilohertz. Now, having said that, that's only with the modules and the libraries that I've tried so far, which include the Arduino SSD 1306, this one, my real-time clock lib, again from Adafruit, for the DS3231 real-time clock, and the atmospheric sensor. Again, I'm using the Adafruit libraries for the BME 280. So they're the libraries I'm using. Now, the key takeaway is you've got to be careful. Now, I did a bad thing. I was assuming that the command wire.setClock worked. It's only because I happened to use the scope to actually look that I found out that it wasn't actually doing what I thought it was. So the key takeaway is just be careful. That's all of the warnings I can give you. But I will be testing some other libraries and other modules. I have a 3-axis accelerometer, a compass, magnetic sensor, a GPS sensor, and a few other things I'm going to be playing with over the next few weeks. And if I find anything weird about the I2C speed setting, I'll let you know. But apart from that, I'll leave the video there. And I just want to say thank you for watching. And if you have any questions, please feel free to put them in the comments below. As I understand, everyone has a different level of experience with coding and electronics. So feel free to ask any questions that you want. I'll be happy to try to provide an answer. Anyway, thank you for watching and have a good day.